Okay. Thanks to Elam for drawing the trapezoid correctly. And then I went ahead and imposed axes. I didn't ask Elam to do that. So we have omega 1 and omega 2 and delta t. Now in class last time I used omega I and omega f, but omega 1 and omega 2 is fine because that's what I used in the homework. Okay? I think. Wasn't it? Right? And last time we saw why the slope is this. Now, when I label a slope on a trapezoid, I put a rectangle around it, and I don't know if I said that last time, okay? I don't think I did. But I talked about these a little bit in another class, so I'd be a little confused, okay? Just to be sure that I did what I thought I did. Okay, so anyhow, there's your slope, right? This is the slope, and the slope is the average rate of change of omega with respect to t, and that's average angular acceleration. And we use a symbol alpha for angular acceleration, so I'll call that alpha sub average. Okay? Everybody all right with that? I mean, that's what we did last time, so hopefully you're all right with it. It's in the videos and everything else. Okay, so the area is should have told you to draw it a little wider, but it's okay, we can still do it. That's the area. So, all right. And since I'm going to write out the expression so everybody can read it, the area is this, which is the average angular velocity times delta t, which is angular displacement. Angular displacement. I'm abbreviating because I want that board space over there. And that's delta theta. Change in your angular position. It's measured as an angle. Okay? Got that.
What are the units for theta? Is that degrees?
Well, if this is in counts, and this is in degrees per count, then what do you get when you multiply the average of this times this? You get degrees per count times counts. If you do fractions, you see you end up with degrees. Okay? Now, that, you know, the default unit would be radians per second if you're doing SI units, right? Instead of counts, you'd use seconds. Instead of degrees, you'd use radians. And of course, you can convert between radians and degrees, so there's no difference except in the way you label your units. And of course, if you're doing it in radians per degree, you better express these in radians per degree, right? Okay, does that make sense? So you see the relation to the fundamental theorem of calculus already, right? Doubt it. But maybe. I mean, a lot of smart people in here. I can certify that, since I've had many of you in class before. I can certify the certifiability of some of you too, but I won't mention that. Okay. And I was just kidding in the class. Okay, so we get, you know, delta theta is this, right? So that's omega 1 plus omega 2 over 2 times delta t. Now, there's a little confusion, typically confusion, if you don't think and don't draw that picture in your head. You could easily put a delta t here or a 2 here, couldn't you? Wouldn't make any sense at all. Well, if you're an engineer, you just think about formulas. You don't think about what they mean. If you're trying to make everything work, and you just make sure you get the formulas right. Okay? Well, the way you get the formulas right is to understand what the heck they mean and not confuse the 2 here with the delta t here, because it wouldn't make any sense. Of course, you've got to understand the sense of why these things are true. And that's what we've been talking about. Okay? And which you'll understand better after you do the exercises. Okay, so we have this, right? You know, we also have alpha average equals omega 2 minus omega 1 over delta t. Two simultaneous equations in two unknowns. I'm not going to solve them for you. You have to have the algebra to solve these things. Now, if you make a good attempt at solving them and get stuck, then maybe I'll help you. Well, certainly I will. If you make an honest attempt to solve them.
What are you supposed to solve?
Well, I tell you in the homework, I say eliminate delta t. How do you eliminate delta t?
Divide by delta t.
I'm sorry?
Divide by delta t depending on what we were doing.
Oh yeah, you divide this by delta t, it's gone, except it's over here on this side, so that's not going to help.
Then we would multiply delta t by out by the other average, and then divide it by a average.
Except you got your numerator and denominator wrong, but your procedure is correct. You solve one of these equations for delta t and plug the result into the other one. Right? Okay? So we eliminate delta t. Okay? And if that's not totally obvious to you, you really need to review simultaneous equations. Be a short review, it's not difficult. Okay? Which is exactly what I tell you, I think, in the homework assignment. Okay? I'm not sure I said that you have to solve one equation for the other and then substitute in the other one. Okay? Shouldn't have to, but I knew that there might be a little confusion on it. Maybe I would have to. I had hopes, but...
I just solved both for delta t.
Well, you could solve them both for delta t and set those two things equal also, right? If I solve this one for delta t, if I get what? 2 delta theta over the quantity omega 1 plus omega 2, right? Solve this for delta t, I get omega 2 minus omega 1 over alpha average. And I set those two equal, and I have a perfectly good equation, right? Okay? And then what other variable could you eliminate? Well, the only other variables that we have common to the two equations are omega 1 and omega 2, right? I mean, this one has a delta theta, but this one doesn't. This one has an alpha average, and this one doesn't, so we can't eliminate either of those. But we could eliminate either omega 1 or omega 2. Okay? Well, I think I advise you then eliminate omega 2. Now, if you eliminated omega 1, that would be okay. But the standard way the equations are written, it would be omega 2 that you would eliminate. Okay? And now you got 4 equations that have the properties that I say they do, and you need to verify that and write it on your paper and show me that you verified that. Show me that it's true. Okay? Each of those equations will have 4 variables. I mean, each of these equations has 4 variables, right? Well, if I eliminate delta t, well, I'll have the delta theta instead of the delta t, so when I plug in here, I still have 4 variables. If I eliminate omega 1, then I'm going to get an equation still in 4 variables. And then you can look at those 4 equations and verify.
I sent her an email and I said,
I talk in the hall too, I can't complain. And I'm a lot louder. You can verify then that any combination of the 5 variables you see there appears in at least one of any combination of 3 of the 5 variables, pick any 3, it will appear in at least one of the 4 equations that you get. Meaning that you can do what I said before. If you know 3 things, you can find the other 2. Okay? So you need this. Yeah. So make sure you've got this and get it kind of quickly so it sinks in. Now, the other thing is, in the situations that you've been looking at, you could have a V1 and a V2 and a delta T. V1 being velocity in dominoes per count or meters per second or whatever. Okay? And you can do exactly the same analysis. And you get I did that. 2 equations that are totally analogous to these 2 equations. And I'll be asking you to do that. And give you a few instructions so that you can apply it to what you see here. Okay? In other words, you can apply it to your measurements. And the only thing you don't necessarily know is that delta S is linear displacement. And your textbook will probably use a delta x for that. Matter of fact, your textbook will probably use an x and an x naught, but delta s would just be like the x minus the x naught, but I'll explain that. Okay? So, right there. Now I want you to really know this, and I want you to know those equations. Okay? Because you got to use them. That's what we do in the first, many times during the course. Okay. Now, one more thing, but we'll do it off camera.